Welcome back. In the second part of this video on graphing straight lines, we're going to look now at just the intercept method. Okay, the gradient intercept method is a fantastic method when you're using straight lines because it's very structured, it's very precise, but only really works when you've got a Cartesian coordinate plane in front of you. All right, and it only really works for straight lines because it relies on this whole idea of gradients. However, okay, as we move further and we start getting into more complex curves, so parabolas, hyperbolas, and exponentials and all of this sort of stuff, this whole idea of the intercept method becomes much easier for us to use as things get more complex. So from here on out in the course, you'll mainly see me use this intercept method whenever I'm graphing straight lines. One, because once you get proficient at it, you get much faster, I find. Okay, and two, you use this for a whole range of curves rather than just straight lines, okay? So this is my preferred method, all right? So I'm going to take you through the steps. It says let x equal 0 to find your y-intercept, let y equal 0 to find your x-intercept, and then you connect them. So it's very similar to what we did up here in the fact that we're just connecting dots together. But let's just have a little bit of a chat about why we're letting x equal 0 and why we're letting y equal 0 to find our intercepts. When you think of your Cartesian plane, okay? What I want you to understand, you have your y-axis and you'll have your x-axis, okay? So while we go along the x-axis, we'll just imagine this as a number line. This vertical line here occurs at the point where x equals 0, the origin. So anything on this line, any y value along this line, is happening when x equals 0. So when I let x equal 0, we're going to find that point where any curve, in this particular case a line, will cross this axis. Vice versa, when I work down the vertical line, when I cross the origin, that's at the point where y equals 0. Okay? Alright? Which means that when I let my y equal 0, my value here, wherever I have my straight line, alright, crossing, that means I'm going to find where it intercepts the x-axis, okay? So just to show you with a quick graph, if I draw my line here, alright, it intercepts a y-axis here where my x equals 0. And it intercepts the x-axis here, horizontally, when my y equals 0. That's how this method works, okay? Alright, so that's what we're going to use now, and we're going to practice with it, alright? So, let's move on to another sheet. So we're going to now graph these several lines using the intercept method, okay? And I'm going to walk you through the steps. They're a little bit more involved than what you've done previously, but we're just going to talk about them, okay? So in this particular step, what we're going to do, all right, we want to find the y-intercept first. So I always like to write, to find y, let x equals 0. So we're going to find the y-intercept first, okay? So if we want to find y, oops, sorry, my apologies. If we want to find y, we let x equal 0, and we move from there, okay? All right, so when I let x equal 0, I basically take the value of 0 and I plug it into my equation using substitution. So now I have 0 plus 2y equals 4. Essentially, that's just an equation of 2y equals 4. I then rearrange to get y by itself, divide by 2, and I end up with y equals 2. So this is my y-intercept, okay? I'm just going to use int for short. So y equals 2 is my intercept, all right? Now I want to find my x-intercept, so I'm just going to go down here, all right? So to find x, I let y equal 0. Okay, so in this particular case, if I want to find one thing, I let the opposite equal 0 in terms of the variables, okay? So I'm going to let my y equal 0, so I end up with x plus 2 times 0 equals 4, okay? Which just gives me x equals 4. So that's my x-intercept, all right? X-int equals 4. I want you to understand that we are basically now done with the process. So we're actually able now to graph this. So to graph this line, we don't necessarily have to use a Cartesian coordinate. We can if we would like, but we don't have to, particularly when we start ending up with fractions. All right. So what I like to do is I like to put my my y-intercept down first, okay, and it's going to be a y-intercept of 2 on the vertical axis. Remember, y is vertical, and then we've ended up with an x-intercept of 4. So to give myself some sense of scale, all I do is I just label where everything happens. This is positive 4 and positive 2, so I label them accordingly on my Cartesian plane. And then my final step in doing this is I just connect where my intercepts are. You'll notice that we don't have a need to have anything to scale, which is very, very useful. Sorry, let me say that again. We don't have a need to have anything like we do on these graphs because we just have to draw where the intercepts are. These intercepts give us our idea of scale, as long as we're being roughly appropriate with how far along the graph is. The final step that we need to do is x plus 2y equals 4 and label it. Alright, this is very, very useful for tricky numbers that involve fractions, alright, particularly if you get x and y intercepts that are very, very nasty fractions. Okay, so let's have a look at the second one. Alright, feel free if you want to work ahead and pause the video and see how you go, but if you want to follow along with me, then that's fine too. So it's the same process, okay? I want to find my y-intercept first, so I say to find y, let x equal 0. Now I'm doing this just to communicate, right, because I'm a good mathematician. I want to communicate with the people that are reading my solution exactly what I am doing. So I want to find my y-intercept, I let x equal 0. So I end up with 0 plus y equals 7. So y equals 7. That's my y-intercept, okay? So y-int, all right? Same thing, all right, to find x, I let y equal 0. All right, so the same process is going to happen. So that means we end up with x plus 0 equals 7. So x equals 7 in this particular case. All right, and this thing here is my x-int. All right, my x-intercept. All right, so now let's just add it on the graph. So our y value is going to be 7, our x value is going to be 7. We just come back to our graph here. All right, we just label our intercepts. We know y is going to be at positive 7 and x is going to be at positive 7. And then we simply just connect the dots, just like before. Okay? So this is x plus y equals 7. All right, this is the exact same way as if we were to graph this using the gradient intercept form. I could just rewrite this as being in gradient intercept form, so I just move the x to the other side. Okay, so I'd end up with y equals minus x plus 7. So we end up with a y-intercept of going at positive 7, all right, and then our gradient is negative, so we would go down 1 and across 1 because our gradient is negative 1 over 1, all right, and we would end up with that line that crosses exactly like what we were doing. This is just a little bit faster than having to go through and do dot to dots, okay? So let's do the next one. This is in gradient intercept form, and if you have a Cartesian plane, you could do that, okay, but I'm just going to show you how to do it using the intercept method anyway. So I want to find y. I tell the reader exactly what I'm doing. Okay. So I end up with y equals minus 2 times 0 plus 3. So my y-intercept is equal to positive 3 because minus 2 times 0 disappears. Okay. And you'll notice that any time I do that, the number that's floating by itself when it's in gradient intercept form will always be the y-intercept, okay? You guys knew that just by looking at the fact that the y-intercept exists. So both methods marry up, okay? Same thing, all right, I want to find what my value of x is. So to find x, I let y equals 0, okay? So I end up with 0 equals minus 2x plus 3, all right? And now we start solving this equation. I'm going to make x by itself with a positive 2 because I don't like to work with negative numbers. So I take it to the other side and change the sign. So 2x equals 3. And then to get x by itself, I just divide by 2. Take it to the other side and change the sign. X is equal to 3 over 2. That there is my x-intercept. So my x-intercept is equal to 3 over 2, which is roughly 1.5. Okay, if you get on a calculator and you type that out. And my y-intercept is equal to 3. All right? This is what I mean when we talk about making sure that we graph these things correctly. All right? It makes it a little bit easier when we have more difficult graphs to work with. So let's just go through and do that. Remember, our y-intercept in this particular case was 3, and our x-intercept was 3 over 2. Okay, so I do my y. All right, and then I'm going to do my x-intercept as being 3 over 2. All right, and I just label it exactly as it is with a fraction. All right, I want to try and keep my answers exact. And then I just connect my intercepts together. Okay, I draw my line, I go a little bit past it, and I just label my graph as before. Okay, so let's do the last one. We'll do the last one together. All right, this one looks a little bit more complex, but I assure you it isn't. Okay, I find these much easier to do if you have nasty numbers with the intercept method. So let's go and we're going to find y. So to find y, let x equal 0. So I now have 4 times 0 minus 2y equals 12. So minus 2y is equal to 12. Okay, because the 4 will disappear, which means y will give me, negative 2 is going to be divided over. So 12 divided by negative 2 is negative 6. So that is my y-intercept. Okay, now let's have a little bit of a look at doing our x-intercept. So to find x, we're going to let y equal 0. Same process. I now have 4x minus 2 times 0 is equal to 12. Okay? Alright, the minus 2 will disappear. Okay, and we end up with 4x equals 12. Divide by 4 on both sides, and x will be equal to 3. Okay, so now let's just graph that on our graph. Okay, and we'll have a little bit of a look at it. Alright, remember our x is equal to 3 and our y is equal to minus 6. Okay, so I'm just going to do it just up here so you can see what's going on. So we have minus 6 down here, and we have 3 up there. We just connect our dots together. Okay. We draw our line, and then the final thing that we do is we label it with our equation. 4x minus 2y equals 12. Okay, so that's the intercept method. That's how we use it to graph things. I do much prefer this method. It seems like a lot more work, but I do promise you in the future you will use it much more when we're graphing nonlinear curves. Okay, thank you very much.